Hello, hello. Let's get started. Today we have an off-schedule stream, and today we will do a lot of cleanup and a lot of work that we haven't finished yesterday, but we definitely started. So first of the tasks from yesterday was watchdog example. I spent quite a few hours trying to understand how to implement it, and it just didn't run. And in the end, I decided that whatever, Windows watchdog has window, and independent watchdog can work without a window, so I will just remove the window functionality so that I would never have an issue of target using this function without knowing how to reset it properly. I don't want to bother like a user potentially in the future who is not me, or me myself in the future, to need to know that there is a bug with the first reset. So that's what we will start with. It's like a 10-minute comment out, remove all the code that will not be running, and then we will go to debug protocol improvements. We have quite a lot of work to do there. I was cleaning it all morning today, and this is quite a lot of work, but this will be a huge payoff in the future, like an insane payoff, because I would imagine, or at least I hope so, that we will take this protocol with us for like many, many years to come. So that's why I don't mind at all investing multiple days into it. And this is what we will do. After all, I think everyone is busy today mostly. It's evening or midday for some on Sunday, so let's just do some chill work. Okay, so let's first remove all the necessary Windows watchdog components. And for this, let's write the comments that this example doesn't work, and we also need to write this comment for another example, and we will need to remove a few functions. So let's do it. So this example doesn't run properly. There is a node bug for VDD that for whatever unknown reason, whatever requires longer duration for the so let's do it like this. For the initial reset of the IVTG, because it is for independent watchdog, because Windows watchdog or window watchdog, not windowed, works pretty fine. So initial reset. For example, if the watchdog is set up to have 500 millisecond period, reset period, and 200 milliseconds window, though it's supposed to reset, not to be resetable if I call the reset at 210 milliseconds, but this doesn't happen at the first reset. The first reset has to be done later, and for whatever reason, and after that 210 millisecond resets for whatever reason work. So this is our explanation, and we will copy it multiple times. So, and I need to copy this a few times so that it is obvious to look at this line. And we will also need to remove this code and this code and this code, and we will not copy, but rather comment out this, because this function will also be commented out, because it doesn't work and I have no idea why, so we might as well just remove it. So let's go to the watchdog file. And let's comment out this function. And let's move our comment here as well, because it's important why this function is commented out. So let's note it. It's very important because this is not a functionality we support or will support for quite a long time, I would imagine. And let's note it here as well. And let's completely comment this out. So this is not supported now. And we don't want anyone to be able to use it, but we would like to have a note here that we were trying our best and we we failed. It happens. Sometimes it just happens and you need to accept it unless your life depends on it, and our life doesn't depend on this particular feature of a watchdog working. So it was just a nice feature to have, but I'm not a big fan of wasting like 2 days investigating this. Now, we also need to change an example 4. So let's do it. We change example 3. Let's switch to example 4. Like that, and like this, and it will not work, of course, because we removed this function. Else, actually, let me also see if I remove this here. I did. So will this example do anything? It will just blink LED, which is fine. Just absolutely fine, so be it. So let's go to example 4. We are here, do the same here, and copy our note that this example doesn't work properly. Okay, at this point, we made 2 examples not obsolete, but rather unfunctional, removed. We keep them in the code because this is functionalities that one can expect while reading the documentation, but we also need to show them that we have a bug. Maybe it's a hardware bug, maybe it's a software bug. Like, I don't know. But to not confuse people, it should be here, it should be in examples. Okay, so this is done. I might as well just build this to make sure it builds. Build 3, just to make sure it builds. It does, and now we can do a commit. Let me quickly do this. One moment. It will be MCU SDK. And it will be G4, of course. Made sure that E3 and E4 are explicitly mentioned as unfunctional. Commit. So we done first task for today. Quite productive. And let's quickly switch to the second task then. And the second task is actually improvements of the debug protocol. So one moment. Let me quickly grab my emoji to show on screen. This here. Done. Now, what will we do in our debug protocol? We will actually do quite a bit of interesting work because I would like to upgrade the debug protocol to something very useful and very functional. Because currently what debug protocol allows is reading error codes, as we saw yesterday, reading debug buffers, as we saw yesterday, and reading streams of data, as we saw yesterday. And it also allows to send arbitrary commands that do not mean anything on the master and can be interpreted by the slave freely, like in any way in capacity. But we don't have a functionality to set any data in the microcontroller yet. And this will also be useful for debug as well, but also further than debug. For example, if I would like, not if I would like, but this is a task we would like to solve, we try to solve, is to be able to control, for example, speed or position or anything of the motor from the computer. then this is what and why we will implement today. So let's close examples for today. We will not work with them. No, we will work with the debug example. I would assume it will be much easier than going and changing things in our motor controller firmware. So let's close this project because we are done with it. And let's open our debug examples, and we will use our first example as our playing grounds, as a playground. Here we will have only the things we need important, which is here, our H and C files, and our Python files that I moved here yesterday. So now we will need to implement two big features. First is write command, as I explained, and the second one is multi-stream support. And the multi-stream support means that right now there is only support for a single stream, and stream is just a way to say to microcontroller, please start sending me data all the time, constantly. Like what data we don't know, we can't set it up. We just say like, if you have a stream available, please send it to me. And what I would like to implement is for the microcontroller to be able to say that there are multiple streams available. Which one do you want? And for master to say, I would like to read stream 7, let's say. And the microcontroller will send the stream 7. But write command is first. It should be easier to implement. And let's just do it. So here, let's see our codes. Our codes are here. What do we have? We have established connection code. Sure, this is usable. Close connection code is also usable. Keep alive code is actually not usable anymore. I think we can just delete it like right away. Let's check if it's used anywhere, just to be sure it is. It is here, but I don't think it's used, right? Let's see our Python code, but I actually don't think it's used anywhere. Yes, I'm confident that I should just remove it. So let's just do it. This is fine. Then we do it like this. Read error log, sure. Read debug buffer properties, sure. And here we will need to add a note, which is also important. Codes 11 to 30 are codes for the particular debug buffer that master may want to read. So these codes exist, they're just not specified here. What do we have? Next, this will change, and this will change now. So how will this change? We will do today. Implement multi-stream support with at least 4 streams available at the same time. Why can we or may we or need shall we need 4 streams? For example, for our motor control system, we may want to stream data for position loop, speed loop, and current loop separately. And also we may want to stream data for a particular application. For example, we have a SCADA robot or an inverted pendulum, and it has its own set of points. And in particular circumstances, when we debug something or set something up, we may want to be able to have access to all the data without a need to restart the microcontroller to flash new firmware. Like, this is why we do it. So these codes will change and these codes will change. And I think we should just go like this. I think all the firmware will just work. We up our code up, and we also need to do this in our Python code as well. So let's go to our protocol in Python, and let's just bump the code here as well, like this, because we will need to work with 2 sites at the same time. Now, we freed quite a bit of space for us, but we also support multiple generic requests. So let's see how many, 16. So we need to also note a similar note here because we have like more codes that are used but not mentioned, which are 61. Actually, I think we should be, not be, but we should support only 15 because if we support 16, we kind of use code 0.x70 and 70 is kind of in new group already. So I think we should just do it. Let's say we will support 6f, which means the last number before 0x70 are codes for particular generic requests. And let's go to here, remove this, go to our implementation, remove it here as well. And let's make sure here that we use 15 here, and let's notice we use only 15 callbacks. Oh, hold on a second. Am I a dumbass? Hold on a second. Base code. And if we use a base code... Oh, I am a dumbass after all. Okay, so it can be 16 because we use 60 as 0. It's called 1, but it starts from 0, so... Okay, I am a dumbass. I am a dumbass. Happens to the best of us, I would assume. We can have 16 here. And this will still be correct, but we need to use like this. So these codes are available for usage, and they will be used correctly. And now let's define our new codes that we will implement right now, which are debug, ITF, and it will be parameter write request. Go. Okay, and the codes will be 70 because it's available. And now we will need to think how it will work exactly. So let's also implement it in our Python right away. Okay, I need to... No, this is not the file I want. Let me actually clean my open files up. This is it. And let's copy this and say message. How did we call it in C? Exactly. Parameter write message. Parameter write. Like that. Is it correct? It's message prefix plus this plus something that we will add later in the implementation. Very nice. So now let's think about it. This message is something that the master will initialize. So slave just needs to do the thing. So let's see how our callbacks are implemented actually. So if the message is this code or this code, we just acknowledge this and we find out the code of the message, not the message, but the function we need to call, and we just call it. So it's very simple. Okay, we will do something similar. I don't think we need to like complicate things at all. I also think the tabulation here is broken. No, it isn't. So if our message of 2, which will be an index of a message. Hello, Mr. Das, how are you doing? If it is equals to our command write code, which is this one, then we know that we are writing the command. So when we are writing the command, we need to acknowledge that we are doing this exactly. Привет, можно тебе на канале? Можно. Я отвечу на русском, хорошо. Добро пожаловать в чат. Okay, so let's see. We acknowledge the command, and now will come the hard part. And the hard part will actually be in a way that now we need to understand how do we understand on the microcontroller side what parameter do we need to change, like how do we specify this? And this is like actually not easy. So the format I would say it should work with, it should be, let's think about it because it's complicated somewhat. So for now, message will be our prefix, which is this, and then our code, which is this. So what else do we need here so that we can write anything? We need first a parameter ID. So it will be param ID. And then we also need param type, because we need to know the type of the parameter before we apply it. Param type. And after this, we need a parameter itself. And the parameter itself, the length of it will be different depending on the type we specified. Because if we send a uint8 parameter, we only need 1 byte. If we specify a float parameter, we need 4 bytes and stuff. So this will be variable. So let's assume that the format is as following, and let's analyze it. So we will have uint8 param. Oh, I know how to do it. Okay, I have an idea. Param ID, and it will be our message of 3. Actually, here we need to make sure that я правильно понял, что делаешь управление мотором через коммуникацию по UART. Не совсем, я делаю управление мотором в целом, а коммуникация по UART это просто интерфейс, который сейчас доступен для отладки и управления. И потом на плате также есть CAN, но CAN пока не реализован, потому что это немного сложно, немного время затратно, и со временем будет CAN. А UART пока просто потому что это удобно, легко и просто. So, sorry for my Russian. В чем заключается multistream debug? Идея в том, что у тебя может быть стрим параметров. Например, у тебя есть ток, параметры контратока, параметры контрскорости, параметры контрположения. И там по несколько параметров. Например, ошибка, сигнал управления, интегратора, в чем угодно. И, соответственно, ты можешь при желании стримить эти параметры на компьютер, сохранять их в отдельный файл. Например, если ты хочешь получать только одно из этого. И сейчас это не реализовано. Сейчас реализовано, что микроконтроллер знает только один стрим, и ты можешь к нему подключиться или нет. И, соответственно, если тебе нужно поменять, например, ты ходишь с контртока на контрположение, тебе нужно перепрошивать контроллер. В этом ситуации. Okay, so let's keep going. I'm sorry for answering in Russian, but if you have questions in Russian as well, I can answer them in Russian for sure. What were we doing? We were checking. Giving this protocol type, we need to make sure that we have at least 6 bytes in the message, or else it should be an error, because the minimum possible setup here is single byte here, and at least single byte here. Otherwise, we have an error. So let's see. Do we have a parameter that specifies the length? Oh, actually, we have a message length of 3 here, so we cannot do it here specifically. We need to move it to a separate else. So else, actually, now that I'm thinking about it, I think that this check is absolutely unnecessary any longer. Because everything should work as is if protocol is fine. So let's actually remove it completely. Let's remove it completely, and we will not need else here, and now it can work as intended. So, and this can go one tabulation down. One tabulation down. So. Okay, so here we actually need to check the length of the message, and we send it as a parameter. So let's use this parameter. Do you like working in the STM32 Cube IDE, or do you prefer a different IDE? Okay, so if I was capable or able of working in, let's say, VS Code, I would probably switch to VS Code. And it's kind of possible, especially currently in the modern day, because STM microelectronics currently try to actively support CMake projects. So it is possible to work in VS Code, but switching is kind of a pain because a lot of my examples, a lot of my templates, a lot of my work currently is stuck in CubeIDE format. So I can't say I hate it, but I also can't say I love it. And the part of the reason is not the development experience itself, but rather the experience outside of development. For example, all the compiler commands, all the setups are done in UI, and this is very uncomfortable when you go into more advanced things, like for example CI/CD, when you would like to build your code on the server and verify your code on the server and run unit tests, because in the CubeIDE format you cannot run unit tests, even though the firmware for microcontrollers can be unit testable. So I would say that CubeIDE is limiting in a way, but if you are only starting, if you are thinking about starting, it is absolutely fine. It's workable, it's usable. Just don't expect it to be able to do everything. But yes, in the long-term future, I would for sure try to switch to a CMake-based project for STM32 and work in VS Code, because it will solve a lot of issues long-term, especially if we think about like more professional like development. I hope it answers your question. Okay, so message length less than 5, 6. This should be an error because we know this code, but we expect at least 6. Do we have a debug? We have, so we can log the error. So log error, let's say it will be 5, 6, 1, 3, whatever, to do that proper error code. And what else? After this, we know that we are working with the data we can work. And we need to actually send a not acknowledgement and return. So this will be a correct way to handle it. So let's say that we don't know what message we are working with, which is knock, which means not acknowledgement. And after that, if it is not the case, we can send an acknowledgement and we can start handling the data. So let's do it. And first we will have our 8, which will be param ID. And this will be message of 3. And then we will need... Actually, I know how to do it properly now. Okay. Param type will be also T, which is param type. And it will be message of 4. And now, based on the param type, we need to actually save the data. Or shall we? Let me think. Because I think I can make a copy. Because the question here is, for example, if we will use something like uint64, which I added support today in the morning. I like what STM32 CubeIDE offers, but for me it feels more that it slows my development down, probably also because I'm not used to the shortcuts and so on. I do know how to use a CMake project instead. Some things are annoying to set up, work with. So you are using CMake to work with STM32? Or CMake in general? I think one big thing for STM32 CubeIDE was that before it's integrated CubeMX, and it was very useful. But now that they forced everyone to use CubeMX separately because it was slowing down their development environment, there is no such a big force driving people to use CubeIDE separately, or rather not separately, but in general. So there is more freedom of movement if you want to explore things like CMake and VS Code. But the fact that you are using CMake, like I haven't used it yet. Like I know how to use CMake in general for C++, but I haven't tried it for microcontrollers. And actually, maybe in a few streams, maybe in a week or so, we will try to do it. Because if you recommend, we might as well see me struggle, because I struggle a lot on this channel. And if anyone wants to try to see me struggling with CMake setup for microcontrollers, I might as well indulge such desires. Just ask me nicely. Okay, so what I was explaining. If I hadn't uint64, then this parameter will have like 8 additional bytes. So we will expect something like 5 plus 8 bytes. And if we have something like uint8t, we will have 5 plus 1. And the question here is that at this point, we need to call a function. So we need to call a function. Okay, actually, would love to. Okay. So then we will schedule a stream like next week or maybe a week after this at some point to make a CMake project, to learn CMake for microcontrollers on stream. So follow and stay tuned to see it. But for now, let's continue working on our debug. Actually, now, given that I have motivation to learn it, I actually think that I would love to switch to CMake eventually. And maybe this push from you and maybe some other people who would like to see me do it will be a healthy push from me as a developer to improve the code quality. So we will see. We will see when the time comes. Before that, I have a few ideas that we need to implement to like finish our driver first. Okay, so call a function here. And now that I explained the situation, the answer is obvious to me. The function should be, let's actually specify it. It will be a callback like this with different name. It's Onion. Hope you guys are having a fine day. Hello, Onion. We are. How's your project rack like going? Have you finished? Have you moved forward? How's your day? Okay, so this will be void function, of course. And it will be a debug, ITF, and it will be a handle. And how did we call it? We call it parameter write handle, parameter write request. And it will be a callback. So to make a function callback in C, you need to specify it in an H file, and also to not break anything, you need to force your user to implement it, but you also need to be able for this function to not break your code if user doesn't implement it. And for this, there is a special flag that's called weak, which is a weak definition of the function. And the weak definition of the function means what? It means that in case your compiler doesn't find a proper definition of the function, this definition will be used by default. But if you have a proper definition of the function, it will be used instead. And also think there should be 16. Right. So let's do it. A weak definition so that our compiler doesn't break, even if we don't have this implemented in the code. And if you want to implement it in the code, what you do is you just copy the body and go to your main and just paste it anywhere, and you just implement it. And when you do it without a weak here, so there must not be weak here anymore. So like no weak here. This will be always selected to be run. All good here. I had a little lazy day regarding the rec, but I have been 3D modeling and printing other stuff for sure. Sounds good to me. It's weekends after all. Nothing wrong about not doing anything specific, so it's absolutely fine, in my book at least. Okay, so let's keep going. We provided a callback, and let's call this callback. But this callback is actually supposed to take parameters, and parameters should be our uint8t param id. So the code needs to know what parameter ID we would like to set, and let's also provide parameter type. Actually, do we need to provide parameter type? Because at this point, the function should... Actually, let's do it, because it will allow us to provide a safety feature, safety net, in case the provided parameter and provided ID mismatch. So let's do it. Let's provide parameter type uint8 t param type, and also uint8 t, and this will be a pointer to param bytes. And I will explain how this will work by an example, of course. So let's put it here. And by default, our Vic definition just does nothing. It's just empty. We'll just ignore the call when it happens. So let's do it. Let's put it here. And let's see. We just call it with our... We call it with our param ID, param type. And then we need to set a value, and our value will be an address of the message of 5. So we take the fifth element of the message and its address, and this is the first byte of the actual data we need to provide function to work. And then function can dereference it as a parameter. That's an actual parameter. Okay. Now, I think the C part is finished at this point. We need to return from function, of course. Return. And this should work. Now we need to implement a Python side of this function. So let's see. Let's go to our Python. And what shall we do here? Let's close this. Is it big enough? I don't think so. It should be big enough. Is it? Looks decent. Okay. So now, let's go and find a cozy place to put our code. Like right here. So let's say def send param write request. And yes, sometimes I write Python code as a C programmer because I'm a C programmer. I'm so sorry in advance. I'm terribly sorry if you will be annoyed or disgusted by my Python code. So let's see, I think the most of the code will be actually copied. Let's actually copy this function and let's work from it. It should take serial and it should take... Okay, how will we call it actually? Let's say param type, which should be of the type of this. And how do I set it as a type? Actually, can I set it as a type of the function? I think so. I think I can use it as a type of the parameter, right? I hope so. If not, we will learn shortly. And also we need to set a param itself, and param itself will not have a specified type because it will change type depending on what we send. And I hope the Python will implement it correctly. Okay. So now let's copy the code and let's see what we work with. Is tabulation correct? It seems like it almost is. Let's see. This will need to be rewritten, of course. To do rewrite. Rewrite, yes. This is actually, no, this is needed. If not, then we say that for this, and we just break. Then here, let's see, if our param, no, I think, okay, param type not in buffer type, then we print an error that we print an error with our fail color. Let's see, and the error, hold on a second, like that rather. And the error will tell us what exactly? It will tell us that wrong parameter. Oh, hold on a second. Did I do something incorrectly? Oh, I'm a dumbass. I am a dumbass. I need to do it like this. Wrong parameter. Type provided to this function. And make sure it's heard, and let's return as well. Here, this is not important. Do we have a way in Python to verify a data type? I actually don't know. Let's actually Google it. Verify data type in Python. Is instant function. Okay, so let me see. Type hello int float. Okay, sure. Okay. So we can verify it. So let's do this. Then we need a separate handling, separate error handling for those. Let's see. A bit of Python copy pasting, of course. Let's see. Correct tabulation. I don't think this is correct as well. Here, if our buffer type is dot value, record type. Hold on a second. No, this is correct. This is correct. We need to make sure that for float it should be type. Actually, how do I compare them? Is there a way to compare it to something? Oh, here. Is instant int float. Oh, I see. So is instant I need to use. Okay, let's do this. Print. No, let's not print it. If not is instance of our param, and we are in float, so it has to be float here. And let's actually write a test function. So it's test.py, and let's actually if name equals a main, boom. Is it correct actually? I'm not sure. Maybe it should be named with capital letters. No, it doesn't need to. Okay. So let's move this code here first to quickly test it without running our whole protocol. And let's see. Test.py. I'm terribly sorry for my Python. Python is not my native language, you know. So let's say test param equals to. Can I specify the type? Say int. Oh, I can. Sure, nice. Like this. And let's see. If our test param, and we also need this, of course, to be present. Let's just copy it for now. It will be very easy. Defined. Perfect. So. Oh no, we need test param, and we also need a test type. And let's specify test type as our. Oh, where is it? Was. What happened? Okay, no worries. Let's copy again. Was. Copy. Paste. Very nice. So, and let test type will be buffer type, and it will be equals to, let's say, I32 buffer. Now I need to probably do it buffer like this, I would imagine. I think so. I hope so. I'm not sure. I'm not entirely sure, but let's see. We are doing this here, and here we check the test parameter against the float, and Actually, let's put float here. And if it is not, we need to print you are dumb. Very nice and very understandable, of course. And I think I need to comment out everything for now, and let's test it. And let's test it to make sure it works as intended, of course. So Python test.py. Okay. Indent block. Is the indentation incorrect? And what the indentation is supposed to look like? Please explain. I think it should be correct, no? Oh, I see. I cannot do it like this. Okay, got it. Sure. Of course. All right. Understandable. Okay, this should run. No, it shouldn't. Enum is not defined. I would imagine it requires some kind of include. Yes, it does require an include. Sure. Like this. And now it should run. It does run, but it doesn't tell me I'm dumb. Why? Don't tell me that this can be considered as float in Python. Actually, let's do it like this. Otherwise, or else, print, you are still dumb. Was? Test type. Hold on a second. I am experiencing issues. A record type should be a byte. It is an int. Okay, sure. Okay, sure. Oh, I think I need to do it like this. Oh, you are dumb. Nice. Very nice. Okay. Some Python learned today. So I'm dumb. Okay, very nice. I knew that. And here, what else? And if we change the type to int, let's say it will be correct. No, it will not be correct because I haven't implemented this. Sure, but let's go like this and let's say hold on a second. Yes, and now let's move it like this, and it should tell me that I'm still dumb, which is correct. Okay. Crazy person talking to himself about being dumb. Okay. So this works, but does the Python have any differentiation between types of ints? It doesn't seem like it does. Like everything in Python is just an integer or not an integer, right? This is kind of annoying, but this is good enough. Like it is good enough. I don't think it can be checked better than this. So let's actually use it as our guideline to change things here. So let's remove this to have more space. Let's go to the function that we were writing. And here we will have what? We will have our prime type. And let's actually not use this because it might as well be incorrect. Param type, and it should be like that. And here is instant of param, and it should be float. Then we will have a same error for everything. Print f, and this will be an error colors, of course. Something error, which will say that wrong parameter provided for type, and let's specify the type. For type, this. and this will be the same for everything. And why do we need to know this? We also need to append the description. Let's see. At this point, we need to prepare a message that we will send. So, and how do we prepare it? We start from byte array. Sure. So let's actually move the code to start our message preparation to was. Why is this using a generic request? What? I think it's incorrect, actually. I think the code is incorrect. Oh, no, it is correct. Oh, no, is it correct? Oh, no, it is incorrect. This should be like this. Right. Message prefix. And this value is second. Yes, this is a proper way to do it. So let's fix the bug. We did. And here, let's move this up. And this will be message sent. Right. Parameter right. Okay, and here we actually don't need this. This is not the way it's supposed to go, but this is the way it's supposed to go. Let's copy actually our format that we expect at this point. And the format is in our C file, which is here. And let's copy this because we need this for our clarification. So we add it here. Very nice. And at this point, we need to send this. So, but this is also already provided here. And we need to provide parameter ID, which we can just do. So let's see. Message of 3 will be, actually, I think I need to append because this message doesn't have what it needs, what it takes. And how do I append a single byte? I think I just append because this is already a byte array. So perfect. My Python is not very strong, but I can manage. It will be param type. Of course it will be param type. So we append this, and at this point we have a message of length 4. So message of length 4, and we need to also provide param type, and we will provide param type here, because if it is an error, we need to exit, we need to abort, so we are failing, and we need to return. Don't forget to not put C-style endings to lines. And if we don't have an error, so the type is correct then, and then we can provide our message, append, and what will we append? We will append we append message type, of course, param type. No, what? Hold on a second. Param ID. Oh, we need to provide more arguments here. We also need to provide param ID here. Okay, so this will be param ID then. And this will be param type. So at this point, we have a message of length 5. And we also need to do something with this. So let's see. Let's implement only a single branch of this function so that we can test it quickly before we write too much code that doesn't work, as we like to do. We test it and then we implement everything else. Sorry for drinking too loud. I'm terribly sorry. Okay. So actually we have 5 at this point, and we also need to we need to append the parameter itself. So how do we do this exactly? Let me look up my examples, because I don't remember. Let's find something useful. Nope. Actually, how do I append it? I think I'm not sure. I'm not entirely sure. I don't think I actually even have a code to append. To append anything. Or do I? Struct and pack. Actually, I need to Google. Convert float to byte array Python. Okay. Byte array struct packed f. Okay, sure. Looks good to me. Let's implement this in our Python script. So we append. Let's see. Okay. I think I haven't copied enough. Byte array value, and I can just append it. Struct pack. Okay, sure. Append struct pack f to pay respect, of course, and this will be a param. Actually, let's call it param value to not confuse ourselves and anyone. Value and value here. Looks good to me. So at this point, do we need to provide anything else? I don't think so. So we should have a message of length 9. Okay, this should go away then. No, but this should also be byte array like this. But is this append then? Actually, I'm not sure if this append, not sure if append will work. Actually, maybe I need to concat the strings rather, but let's try. Because I would imagine that append will just add, but this is a byte array. I have no idea. Let's just test it. So let's remove this. Sending. Let's see. What do we send? We're sending a parameter right. Parameter right request with type. And let's use our coloration. Our beautiful coloration. Okay, blue. This will be quite a string. Quite a long boy. Here. And where the hell am I? I am here. So like this, it will be with type param type. How do I actually write a longer string? I need more space. More space is needed. Let's see. Param type with type. Let's use this. And let's see. Or actually, no, I do want with. Actually, let's do it like this for now. I'm not confident yet, but let's see. I'm not confident it will work, but whatever. Then type and value, and this will be this. I have no idea what it will print, but we'll fix it when we see it. And param value. Okay, so this needs to go. And serial port write message. And I would imagine that message length will be substituted automatically. And we need to wait for the reply. And the reply should be an acknowledgement. And let's see. If device reply doesn't equal 3, wrong answer length to this function, which is correct, response to a wrong request, or rather correct handling of the wrong answer to the request. Here, false return if message equals to NUC, target declined, write param, write request, and without a specification of which exact one, and if it is an acknowledgement, target Oh, it's just not an acknowledgement. Target sent unknown response. Sure, this is also a correct error. But if everything is done, device acknowledged param write request. Very nice, and disconnected. I think it should already work properly. So let's actually make an example for this and see. So let's call it com send com write parameter.py, and let's copy one of our examples without a comment for it. So like here, and where are we? And we are as write parameter here. Close this for now. Copy this here. Remove this temporarily. We don't need any of it. And yes, if it doesn't work, write me a message. You can write me a message anyways. I don't mind. So let's see. Parameters are the same, and this parameter is not needed here for this implementation because we don't save anything here. These parameters are usable. Comport, that's awkward. Is it used anywhere else? Let's see. It used. Okay, sure. And this is not used, right? Okay, whatever. Connected to this device, establish connection. Sure. And this we will do our CDP rather, and write send param write request. And what will we write? What do we have implemented on here? We have nothing implemented, so let's implement something. But first, should we actually look if the parameter will look correctly on a logic analyzer? I'd say so. Let's just look at the parameter in a logic analyzer. It will be just nice to see if it is correctly formed before we try to test it on microcontroller anyways. Because if something breaks, we will need to do it anyways, and if nothing breaks, we just made sure that it works as we expect it to work. So we will not implement anything in C yet. We will just connect our logic analyzer to our Nucleo board. So let me pick it up and let's see our analyzer and our USB cable. And we attach, we connect. We go here. Okay, hold on a second. It clicks, and let's see our channel 1, and let's attach to the ground and wherever the pin is. Oh, actually, no, yes, let's do this. Well, actually, we can. No, let's do it properly. So if I remember from yesterday correctly, it should be like this, but let's Google the pinout just in case. So a Nucleo pinout. Images, please. And let's see, open image in new tab. And the image says that we will have one up, which we do, ground, which we connect correctly, and then PV11, sure. But let's actually do it from the other side. And from this side, we will connect our USB converter. Let's do this. So ground, we will use here. And let's see, it will be our TX and RX. If I remember correctly the allocations from yesterday. And if I don't, it will still work because we will connect to both pins. So let's do this. Shall we? Like here. Okay. Looks correct to me. Let's attach our second probe. to this from below. Uno momento. Looks good. And let's attach another to ground just in case. Just in case we need more ground. Very nice. So let's attach our analyzer to our PC. We don't need to attach. No, we do need to attach actually. We do need to attach our microcontroller as well, but we don't need to flash anything to the microcontroller. We're attaching microcontroller on our development board only so that it provides ground, stable ground connection. This is all we need. We use nuclear board just as path through from analyzer to USB UART converter. It's just a thing in the middle. Okay. Now, code is not needed here. Let's open our DS view. Let's set up our pins correctly. So we should be connected. We are not. Let me connect ourselves like this. And let's see. We don't need so many. We need only 2, but we have 4 for whatever reason. Or, oh, they are the same. Can I? Oh, because these are UART explainers. So this is fine. We need them. So 10 seconds. Good to me. Looks good to me. And now, let's see. Have we implemented everything correctly? Send param, write request. And let's see. What is our declaration? Where is my protocol? Hold on a second. My protocol is here. So close this, look this up, and the protocol is serial port, which is this. Then param ID, which let's say will be 5. Then param type, which let's say will be float, which will be 1. And parameter, let's say, will be 42.1. And we remove this and we close connection. And this should work, or it shouldn't. Who knows at this point, correct? Let's just run it. First, let's scan our COM ports to see where we are connected. We are connected to our COM6. So let's run this script. Python com write parameter com6, and let's see if it works. It doesn't. Sure, whatever. The term Python. Okay, I'm just a dumbass. Happens. Okay, perfect. It actually kind of works. And device not responding. Oh. So I do need device to respond, actually. Actually, I do need device to respond. And for this to be the case, let's actually flash our debug example. And why do I need device to respond? Because before I provide my actual write request, I need to receive the answer to the established connection request. And without device actually handling the protocol, this will fail, and this fail, we will disconnect. Okay, the more you know, as they say. We go where? I don't like this indentation. This looks better. Now, let's go to our example, which is here, and let's see. It should just handle stuff. And will this be enough? It will. So let's just flash it. So let's close this. Let's make sure our motor driver is not attached. It isn't. So we close this for now. And we just flash this. So let's flash it. We are doing this. I hope we are. And let's see. And let's first see that our connection is correct. So let's try to do something that already works, which is com safe error log and com6. So it doesn't work. That means that we have a wrong orientation of connections, or we have similar issues as yesterday, but I would imagine that it is not the case. So let me switch the pins around. And actually, let me open the pinout to not repeat yesterday's hour and a half of the bug. So this is correct. And this should be correct as well. Oh, is it? It is. And here, it should be 1, 2, 3, 1, 2, 1, 2, correct. Let's attach again. And let's attach our logic analyzer. It is attached. Let's touch our Nucleo board. And let's try again. It should just work. So let's see. It works. So now we confirm that this works, and we can actually try to run our analyzer and try to run our this. And it doesn't work. Okay, this is not a big deal. We can fix this. So send parameter request, byte array struct pack. So this doesn't work. So we need to use some kind of different operation. How will we do this? I would imagine that plus operation should work. I'm not a Python expert, so let's just try fixing it. Let's just try fixing it, not by appending, but rather by saying message plus equals. Will this work? I hope so. I'm not sure. Let's try again. Oh, it works. Holy cow, it did work. No way it worked the first time. And device even acknowledged this. No way. Let's do again. And let's run it. And we got a spike here. So let's analyze this. This is connection establishment 01. And the answer is correct. We use second version of the protocol. Very nice. I got lost. Hold on a second. Where the hell am I? I'm here. We go here. So our request from the master is start. We would like to write parameter. The parameter in ID is 5. Let's see. Let's check it. And this is a float value, wherever the numbers are. And 0.1 is what? Is a type, which is float, correct. And ID is 5. And we get an acknowledgement message. And at this point, we close the connection. It just works! It just works! Holy cow. And now let's actually try to do something with this value. actually, let's try to make a motor spin with different speeds that we provide using protocol. It's actually, oh my god! Actually, let's just make it. Let's just make the speed controller work from our PC. So how will we do this? Let's actually do it really quickly. We go here. We actually disconnect this stuff, logic analyzer, and the board, and this and that. Remove this, remove everything, move it to the side. We need this, we don't need that. Okay, sorry, this is taking a lot of my table space. We need to connect this. Okay. So let's see. We are looking at our code here. We need to switch our mode, of course. This is not needed here. Let's go close this for now. Go to our main. Let's switch our control mode to speed controller. And what is our speed controller default task? Our default task for speed controller is 1 revolution per second. Sure, but Sure. And now let's actually see how this will function when we provide the protocol. So I think I speak too fast today. I'm kind of hyped to make it work. I'm sorry if I'm annoying to hear. I'm terribly sorry. Tell me if I annoy you today. Okay, so where is our protocol? Our protocol is here. And what function do we need to implement? We go here, we copy this function, and we put it to our main. We need to implement it anywhere. Absolutely anywhere. Let's put it to some nice place that doesn't handle errors here. Let's do the implementation, and we need to handle the parameters. So how will we handle it properly? So if param ID, let's say we will do it on the param base. Actually, let's do a switch case because it will be faster. Not faster, but we will use a lot of cases, so we might as well use switch here. switch, and we will switch on param ID and case. Like, what did we provide? We provide 5, right? 5. Case 5, and let's see. If the case is 5, we will also return here. We need to specify if param was case 5. Oh no, case 5 like this. This is a syntax. Sorry for confusion, and let's move it a level up. And here, if our param type not equals float type, oh no, f32 type O, this is an error, so we will log it, log error, and the error will be whatever it is, no matter for now. But if this is correct, what we will do is we will use device, speed controller target, and this will be our. Actually, we need to assemble our bytes into a float, and we will do this like will this be in correct order? So let's see. If it works, it works. If actually, let's not do this currently. Let's just add a test variable for now. Actually, we have a test variable. So we have f32 test f32 test variables, and let's use the first of them, and let's say it will be float. We will use a value of a float pointer of, oh, this will be quite a nice thing. If it works, I will be happy. If it works, it will be very nice. Of param bytes. Pointers are not scary, you know. So, is it correct? So float pointer to this value and of this value. Hold on a second. Float pointer of this value. This is correct. This address, and then yes, this should work. And if it works, it will be so much fun. Now let's flash it. Let's flash it, and I hope it works. And maybe I will need to clean up my addressing, clean up my C styling. But let's see. I attach my debugger. Let's flash us here. And let's see. And we run, and let's do our live expressions here. Motor will calibrate and start spinning 1 revolution per second. Very nice. And let's add our parameter into the live expressions. Oh, we have it here. Sure, it's 0. And let's run our script to see if it updates. So I will do it off screen, and we will see update here if it works. So I'm sending the parameter in 3, 2, 1. It worked! It worked! It just worked! It worked! If anyone needs an explanation of what it means, I can explain it. It's not complicated. It's not as complicated as it seems. So I can explain it easily if anyone needs it. But yes, this is a way to convert a uint8 array to float if you know how it's packed. I'm proud of myself. And now let's actually just set it. We will just set it as a value. So let's do this. Let's remove that. Hold on a second. Here, and let's actually also to improve our usability, let's add a console parameter here. Let's add another line so that I can provide a console parameter through console itself. It will be a test parameter, so let's say it will be param. It will be type float. It will be a test only. So I will actually move it separately so it can be seen that it is not. And let's say the default value is 10 or whatever, 10.10, and it will be float test parameter value float. And here I will just say args dot param. Right? This should work. So let's see if this works. So we need to flash this first. Right? Close this and flash it. And let's run it. Let's wait for our motor to calibrate itself. And then let's do what? Let's do this, but we will also provide a param. And let's say our param will be 2pi, which will be like roughly 12.28. It works! It spins faster! And then I can do like, say 20. It's faster! And then I can do like 2. It's slow! Oh my god, it works! Holy cow, why was it so simple to do? Okay. I'm very proud of myself, actually. I am so proud of myself. Okay, but now we have a lot of work to do. And a lot of work to do starts now with us needing to implement all other parameters and implement and test them. And let's see. So let's start with our C implementation. It will be the easiest one to do. Okay. If anyone needs an explainer of this line, please ask. Okay. Let's do a test case. So we will have a test. Actually, we probably need to make a debug example, but we will move it to the debug example later. So test callback. No. Callback to test that all parameter values are functional. Okay. And we will close this for now. We know that it works. We are very happy about it. Let's copy this one here and let's start. The way I propose to test it is we will just add all the parameter types and we will just save all of them to the variables we can see in our live expressions preview. And after we've done this, we implement the Python part and we just send one parameter at a time and test that everything works and we're just happy. Profit. Okay, so let's do it. We have 8 parameter types, so we will have 8 uint 8. Actually, let me move to a better view and to go and find our parameter types, which are here. So let me make a screenshot for myself. I will open it on another screen. Sure, go back. Here. So first is float. Float, callback, float. Very nice. Then we have int 32, cbk, e32. And then we copy it multiple times and we go one by one. It will be uint. And this will be u. And this will be int 16. And this will be 16. And this will be 16 as well, but uint. And here we will have u. And this will be u8. u8. And also 8. But I am not 8. Just for your information, of course. Here and here, we also need to provide 64. So 64 here and 64 here. And this will be you. And this will be me. Like this and like that. Boom, bam, bam. Nice. Okay. Should we actually make a struct? Let's make a struct. It will be easier to see. Struct. Struct. Move all of this here. And this will be cbk. Oops, wrong language. Cbk params. And here I need to change all the finishers. No, I don't. Set the rect. Nice. And put it here. We are ready. Now we are ready, and let's see. We'll use parameter IDs the same as they are types. So let's see. We will have a switch from parameter ID, of course, and we will have cases. So let's see our case, which will be F32 type O. 1, boom, and we will have quite a few of them, one by one. Let's see, this will be I32, this will be U32, this will be me32, 16, U16, this will be U8, this will be U64. If you are 64, you are kinda old. Here, I'm sorry if anyone here is actually 64. No offense, no offense. Okay. We also need to return from all of them. Let's just start moving the code around. Moving the code around like this. And let's put it like that. And boom, and bam, and bam. And spoon, fine, spoon, wow. Okay, so param type is also a separate thing, sure, log error, and here we will do it like this. So this will be float, no, it will be cbk float equals to this beauty. Very nice, and we just need to copy it multiple times and just make all of it work. So one at a time, of course. It will be 3, and here it will be cbk e32, and here we will have uint32t, nope u, but just int32t, and we just keep going. We just need to copy it quite a few times, and we are done here. And this will be our test code. So it's very easy to understand if you know what this means. Okay, this will be like that, and like this, and like that, and like this. And this looks correct to me. Actually, I think we need to check the length at some point, because here we assume that length is correct and it may be incorrect, and we will have a read into the memory that is not, how is it called in English actually? Out of bound request, out of bound read. And we need to do an out of bound read check in our protocol, I would imagine. So let's note a to-do for ourselves. To do here, actually here. What? Parsing 3 arguments. Discards const qualifiers. Sure. Const. This is not a big deal at all. And also, I do need to provide const here. Oh, I know. It argues about not those, but this. We need to make this const. So we need to make sure that our function doesn't change the parameters, which it doesn't and never supposed to do. So let's make sure we add it here. It works, but it's kind of incorrect for now. And here it will be correct. So we can build it and this error should go away, but we also need to add a to-do here. So to-do, and sure that enough bits were received according to the message type. We will implement it later. It's not critical now because we control both sides of the equation. But if anyone else will do it other than us, then it may be a problem for them. Okay, so let's keep going. Make sure this correct. So here, copy this, bump this, change this, and this, and also this. Very nice, very easy. Keep going. And change this, bump this, change this, and this. Keep going. Very easy, very easy. Let's take this, bump this. Ooh, change this, and this. Like that. And 2 more. Only 2 more. Okay, so here, 64. Bump this, change that, and this. And 1 more. And only 1 more. Remove this. Is this a correct closing? It is, and also this is incorrect prototype. We will fix it a bit later. Let's first finish here. Bump. Change. Also, why the hell? I have those switched actually. Let's fix it. I just looked at the screenshot and found out that it looks terrible. Where is it? I have all of them int, uint, int, uint, and I have uint and int here. So let's do it like this. That's annoying, and let's make sure that we change it in Python as well. And it should be on top of the file because this is annoying. Int and uint. Sure. Now it's fixed. Let's go back. Have we changed everything here? Now we can actually switch places between them. Not I, but I. And I will always love you. Okay. And then we can switch errors, of course. Like that. And like this. Nice. So our C side is ready. Almost. Let's fix this definition, of course. And it's very easy to do. Let's copy this and here and let's build it. Let's make sure we don't have errors. We do have errors, but why do we have it? Okay. Yeah, this is annoying actually. We can do it like this. Right. It will work. It won't work. Param bytes. Oh, was. I have 2s. What the hell? Hold on a second. Actually, hold on a second. But there is single s. I think I copy pasted it incorrectly, right? There is only single s. Single s. Hold on. Where the hell am I? Single s here. Okay, so this was a copy paste error, so it should be fine. Actually, everything should build. Yes, everything builds. Do we have any errors? We don't. So we are done with our C side. And we can flash it, but there is no need for flash because our Python side doesn't work, but we can just test it for now. So let's actually flash it. This is commented out, so our motor will just spin, but our debug communication will work correctly. So let's verify it. Let's run it and let's add our new structure to the parameters. And let's open it and we see all the values. And now let me send our request. Boom, it was successfully sent. And let's see, and the value is saved here as... Okay, it was wrong. It was sent into the wrong location. Actually, let's fix it. Let's fix it right away. Let's do it properly because it wasn't sent properly because we expect float at position 1 and we sent it to position 5. So let's change it here to position 1, and what's second argument? It's type 1 and whatever, and parameters, and let's send it again. And let's see, it's saved to a float value as 6 to 8, so everything works correctly. Now, no, thank you. Please go away. Hello, brother. Okay, so let's finish our Python side. So first of all, let's see if it's reads correctly. Connected to port COM6, right? The back connection is established, protocol version 2, correct. Sending parameter write request with type 1, value this, very nice. And let's actually switch this to the parameter type, I would assume, because this reads terribly. So let's do this first fancy update for the readability, and then let's update all the possible options to our write request. So let's go to a new function, which is somewhere here. This is a bit too far. We are here. Okay. For type, param type, and request. Where is the message? It is here. Param type. Do we have any kind of way to? Can I open it multiple times? Actually, I would like to open it twice if I can. You are debug protocol. Yes, I can. Nice. Very nice. Okay. So, and I think I just need to add a tuple, not a tuple, but how is it called? Oh, I forgot the name. The value pair, whatever data struct it is. Map. Oh, map. Yes, map is correct. So we will call it buffer type names, and let's define it as. I don't remember how exactly. I think. Actually, let's Google. Before I embarrass myself too much, let's better Google. So Python value pair maps. Python map. Misclick. I know this is a terrible site. Let's go here. Map for X, A, B, for A in B. Okay. Okay, sure. So this looks like this. And let's say 1 will be float. And 2 will be int 32. Let's say I32. And let's actually not finish it. Let's just make sure that it works first of all, before I type too much. So let's verify that it works. I keep missing my function. Let's actually close this because it annoys me. And this way it will be much easier to find. So here we have this thing we need to use. So let's use it, and I would imagine it should be used like this. Or not, I don't remember. It is not supposed to be used like this. And how do I supposed to use maps? Actually, let's open the Stack Overflow again. Append. How can I get a value of a map? Basically equivalent to Python get a value from a map. Was? Is it even a map, actually? Oh, dictionary. What is Python dictionary? Dictionary. Hold on a second. Append a value. Oh my god. Oh my god. Learning Python in real time. Oh, I need a dictionary then. Oh, I'm a stupid person. I am a stupid person then. Okay, sure. We need not a map, but a dictionary, which is absolutely fine. And let's just do it. And how do we do it? I'm terribly sorry for my Python knowledge. So, the syntax looks like proper brace here, but here we have this and like that. Okay, sure. Now I can use it like an array. Okay, and this should work. Yes, type float value. Very, very, very nice. So let's finish our dictionary then. to be in a readable state. So let's just make it. Actually, I can do it now that I figure out that I can edit to all the functions, and we can have such a nice feedback actually. But let's rename this to F32 because it is our style guide, and 3 will be. And actually, let's not do it like this because this is actually confusing. Let's do it better. And how better, you say, you ask, you want to know better, much better, F32 value, like this. Ooh. And let's copy this multiple times, and I don't remember the hotkey for VS Code, so we will do it like this. Okay. And like that, and let's just remove this. That's annoying. This is a C style. Will it even work? It doesn't. Okay, sure. I'm sorry for my C brain. C brain. So let's see. I32 will write as I32, then it will be U32. Here, then it will be I16, and it will be U16, then it will be U8, and then it will be I64, and we need one more line. One more line, and it will be U64. So here, let's change names, I16, U16, U8, and I64, and U64. And we are done. So let's make sure that this syntax works. Let's run it again. It works. Very nice. Type F32, and value is given. Whew. Okay. So actually, Python com read was Python com save, sure, save error log.py. Let's see what we type. Protocol version, saving log, log version, sure, Anderson's count, sure. Okay, Python save debug buffers. So record type. So let's actually go there and do it nicer. And unpack type, then we will don't need to specify because it will be a record type. Okay, so we can make it much cleaner. So where is our debug protocol, debug buffer save rather, save error log, nope, save all buffers, sure. So at this point, we should somewhere have an array we have here. So let me actually increase this here. This is a mistake. Like that. Make sure it works. It doesn't. I'm sorry. I made a mistake. And what is my mistake? Wait, what? Oh, no. No, yes. Of 2. Was? What? What? Oh, I see. My bad. Okay, so it will be this of that, and this will work. It works. Okay, very nice. What else? We need to find where we split our unpack type and our record type. So see, target, okay, buffer request, wrong response. Now we are at the right response. Buffer I has unknown type. We have unknown type. Buffer I data, a record type. Okay, so a record type will be a substitution of our array, which I forgot the name of course. Buffer type names, sure. This will be buffer type names of this. Nice! Oh my god! Okay, so it's type U32, F32. Oh, this is so nice. And we don't need to actually provide an unpack type anymore. We do need to provide type though, which is fine. But we don't need to provide unpack type, which is also fine. So we can just do it like that, I would imagine. Because unpack type is not important any longer. Oof, very nice. So buffer size, and let's also see if it's the same case for our stream reads. So let's do it. Python com save stream. And it just works because we are on correct COM port. Stream type elapsed. So it what? It didn't. Oh, I know why it doesn't work. Because we switched from position mode to speed mode, and position mode disables all the position code loop code rather, and we added our stream update to the position loop code, and now we don't run position loop. That's why we don't have a response, but we have data. And the data says what? The data says debug connection established, protocol version 2, sure, saving data from active stream, sure, stream ID, sure, field count, sure, per message, sure, effective entry length, sure, bytes per message, sure. This is correct. Entry structure, and here we can actually specify the type of the data, and this will be much nicer. Okay, so let's do it. Where do we have our streaming? Save streaming data, sure. And let's do it. Entry structure, and this will be data type. And here was print entry description. Oh, I see. And we append. Oh, we append it like this. Oh, is it used somewhere actually? I hope it is not used anywhere, because I may as well break something. Actually, let's enable the stream and test it, because if I change it and it breaks stuff, it will be annoying. So let's get our position controller back. So let's flash it. And we get back the position controller, so we just update the stream so the data is flowing so that we can test it. So let's run it. Motor will calibrate before stream is available. And let's see. Motor finish calibration. No. Very nice. And let's now do Python. Do we have float? We do. Com. Actually, we just can just do it like this. Stream stopped due to unexpected error. Oh, I see. So this is used then. That's annoying. Right? Yes, and now it works. Oh. Okay. A mental damage received. So. Is there a fast way for me to change it? I don't think there is. Actually, let me just add to do, because it's kind of a lot of work. Let's add it for later. To do change how the handling of stream parameters work to be able to plot or rather print actual data types instead of the unpack type. Okay, so this will be to do for later. Or will it? No, it will be. Let's not handle it right now. And now we are here. We are back to here. So let's go back to our firmware and let's switch to our speed loop. Actually, we don't need to change it to a speed loop because we still have this available. Okay. And this means that we can just work here. And this means that our example should just work. So let's write parameters and param, whatever, let's use default one, which is 10. And let's see if the value was sent, it was sent, and it was saved. Very nice. Okay. Now, what do we do now? I actually think that I am not a big fan of so many letters on the screen, but we will handle it later because my idea is that I would like to use this protocol so that I am able to send actual control data to my motor controller. And if I do, that I would like to send it like regularly, maybe like 100 times per second, maybe more than 100 times per second. And if I will spit so many lines for each time, it will be absolutely annoying. So, but this will be a redesign of the protocol that we will do later. For now, let's just make sure that it works, that new functionality works, and we can test it. But I think I need a 2-minute break to refill my water. See you in 2 minutes. Get a closer look at the motor. Whoop. Whatever. See you in 2 minutes. I'm back. I was eating a kiwi fruit, as I always do in my breaks, and my midstream breaks. And I was thinking to myself, I think I have two ideas that I would like to implement. I think we will just add them to do for now. Actually, no, we will implement one of them for this function only. Sorry. And we will do another one of them for later. So the to-do that I would like to add will be implement an non-UC mode. The idea here is that the slave doesn't need to provide acknowledgement messages for every request, and this will both help to save throughput. I'm not sure if this is correct spelling. One moment. Oh, it is a correct spelling. Holy W me. And we'll also support a multi-request setup where we have a master that can do multiple types of requests one by one. For example, read error log, write params, etc. One by one. Okay, so this is for later. This is not very hard to implement, but we need to implement it, and I have a terrible habit of coming up with more and more ideas as I go. So maybe this is not the last to-do we will have here. But let's keep going. And the second to-do we will actually implement right away, and this to-do was just me explaining this issue, and I thought to myself, you don't see the issue. The issue is, actually, let me keep the camera and let me turn it off. And the issue is that we have a huge message here. And when I would like to send many parameters, or parameters very often, for example, like 1,000 times per second, this will just bloat the console and it will slow down the performance just due to the console writes. And what I would like, the way I would like to solve it is to provide a parameter which will be is verbose, and if it's not, so none of it is written. So because we assumed that we are using verbose mode when we test something, when we set up things, when we debug things, and when things are working, we just use non-verbose mode. And in non-verbose mode, only errors will be plotted and nothing else will be. So all success messages will be abandoned and not plotted to save everything. So let's do it. And let me remove my camera back. Now, how will we do this? We will do this nicely. And this function, for whatever reason, is open because we have it twice. And we are here to stay. Let's see. And here will be is verbose, and we will have a default value of false. And false. It's capital in Python. Here, if not is verbose, no, if is verbose, then we print it. Let's see. So now it didn't print. Very nice. And due to it not printing, let's actually provide it to be printed because I would like to see how it actually looks on the screen. So where are we? Where are we? We are here. And let's say true. Let's do it again. It prints and it prints nicely. So let's actually put it to false. And And also remove this acknowledgement. And to do this, I already got lost again. Why are you open, brother? Here. So we print, but only if we are in a verbose mode. So if is verbose, boom, bam. So now we send was successful, but we haven't printed it. But given that this example is a basic example, we will have it as true. And nice, very nice. So this is fixed. We can use it everywhere later, but for now, let's implement all of this mess. Ooh. Okay. This append works. We tested this. And now we need to remove this. And remove that, because these were my explainers for myself. And we don't need this anymore because we implemented the format. I hope. Okay, this will need to rewrite. Sure. Okay. So let's uncomment all of it and let's tackle them one at a time. One at a time. And we also will need to do another example. Will we? We will. Okay, but not now. Remove this. So here, we will need to remove all of this actually. Remove all of this. And this and that and that. And now push it one line here, copy this, paste it here. If not, instance param value, and this will be int. Bcolor fail, wrong parameter provided for type, sure. And return and append param type and pack. Okay, so this will be annoying, and for this to work, we need to go and actually look up all our struct types, which are easy to do here. So U32 will have a type of I, big I. And nice, and this is actually, this is all? So, oh, this is so easy, actually. Let's make an example right away, and let's start writing the example. So let's see, new file, example, X, because we will have a proper number for this later. Example F, X, write params.py. Here we will copy this example fully, and here will be to do right, and we also need to add this to here to right. Okay. Here param value will not be provided. This is not a part of the example. These are correct, these are useful. We parse, we save, we use, we write, and here we will use this line many times. Once every type. So, can we be colors? Can we do the same with types? Let's see. Actually, how will we do it beautifully? So all of those will be verbose. This will be different. Let's say we will send 17.7 and using a serial port, and we need to specify two things. First is actually, can I use cdb p dot buffer types dot f32? Oh, I can. Nice, very nice. Okay, given that I can, I will do what exactly? I will look up my function definition. Let's close that. And let's see. Should I move my camera actually so that people can see my console? Not sure. Maybe actually I can do it like this. Good enough, good enough. Okay. So. So, what was I doing? I was trying to look up the definition. So, serial port, param ID. Both should use here, given how we designed this. And now that we only support 2 of them, let's test 2 of them. So, this will be CDP, but it will be U32. And value here will be, let's say, 1, 2, 3, 1, 2, 5, 7, 8. Very nice. And the same here. Okay, and this should work, I would assume. So let's actually try it. Let's just try it and let's see. So Python scan COM ports, we are port 6, very nice. And then Python example x write parameters. It wrote 2 of them, and let's see our debug view here. And we saved both of them correctly. Very nice. Now, let's implement all of them, test all of them, and see if we are doing fine. Now, okay. We open here as a reference, and we just keep going. From int, from type. It's all will be int because Python doesn't differentiate types of int. Take that, Python programmers. And here we just need to change the unpack type to I. Next. Here. Okay, and our unpack type for u int 16 will be h. Boom. Bam. Bam. Next, our pack type for I will be h small, small h, little one. Here, paste u type is b. All right. Keep going. And here, and here our type will be Q. Big Q, capital Q, and here we'll have small q. So, will it work? Who knows? Let's see. Let's add other variants. So just copy it twice. Actually, I can just do it like this. And this will be I. And for I, let's add a negative value just to make sure that types are differentiated. So the value will be, let's say, minus whatever. And let's keep going. The next type is U16. So let's add it here and here. And the value for U16 will be, let's say 20,000 something. I just want to, nice. Okay. And here we will have I, 16, I16 buffer, my god, do I have caps lock on? I do, actually. And for I, let's say minus the same value. Actually, no. Minus different value, just to make sure that we are not tripping what? Here at this and U8. U8, and here will we have U8, and here U8 is very small. Actually, will it even? Yes, it will. It will be. There will be enough space for this value in U16, but U8 is very, very small. So let's add 178. This, it's enough of a space. Actually, more numbers. More numbers here as well. Just to make sure that our parameters are sent properly. Here, we actually need one more. Here. And we need to finish our test function. So here it will be U64. And let's see, I need a calculator to see how big of a value can I put into actually scientific 2 in the power of 30. Oh, wow. Hold on a second. 2 in the power of y, which is 32, which is this value, and I need to add a few digits. Okay, so it will be U64, and the value we need to provide is supposed to have, let's see, 9, okay, 9, 888, 777, 666. Should be only possible to send using 64-bit value. And let's do here again. Call me baby one last time. And let's add a negative value. Here and here. Ooh. And let's actually do, but here we will use like 555, 444, and 333. Like that. So this example is finished. Everything in C should be working. So let's just run it. And I think it should just work. And it doesn't. Something crashed. And we crashed at what point? Wrong answer length for the response sent param write request was. Hold on a second. Hold on a second. So we crashed to infinite loop at some point, and we saved all values but int 64 and u64. Okay, which is reasonable enough, I'd say. And let's see what is wrong with our code for u64 and i64. Okay. It should be actually right now. Should I use memcopy instead? Let's try. Actually, let me put a breakpoint here and let me just restart the board. Let the motor calibrate itself and let's send the data again. Hello? Why do I still see the data? Shouldn't it be reset? Was? Oh, because I'm not in the debug mode. Debug mode crashed? Okay, I'm confused. Let's go into the debug mode again. Okay, and let's run it. Let's wait for motor to calibrate itself. Open the parameters and we have our breakpoint enabled. Very nice. And let's see, let's me send a request from my other screen. I send it and we crashed before this. Okay, very interesting. But The issue here is that it says that device acknowledged the write request for U64, but it crashed for I64. Maybe, but no, we don't have it stored, actually. We don't have it stored. So, let's only send one of them, actually. So let's crush it deliberately. So now, let's comment out all of them, but one, which sends a U64 value. Okay, and let's me move it, and let me open my code, and let me restart the MCU, and it should reset the values. No, it doesn't, and it seems like... Oh, it did. Did it? It did. Okay, nice. And let me wait for the motor to start. It did start, and let me send a request, and let's see what happens. Actually, how will we see what happens? Let's see what happens in the in the protocol function. And the protocol function is where? The protocol function is here. And let's go to here. Yeah. To this section before we send below. So let's remove the breakpoint here. Don't need it. And let's just send the value. So we are here. Let's go to variables and see what we have. Param ID is 8, param type is 8. Sure. As expected, message length is optimized out. This is not nice. Let's switch debug mode so that we can see this value. Debug optimization level 00 for this function. And let's flash again. Because I would like to see the actual parameter. Let's see, let's run. Let's wait for motor to calibrate. Nice. And let's run it. And we are at a breakpoint. Very nice. Let's see parameters. 13. Is 13 correct? It will be 5 plus 8, which is correct. Okay. So this is not a place to crush. So we go in, which gets us here. We go out, we get here. We go over here. Are we crushing on this line? We are. Okay, so we know the line that crushes us. Very nice. So I would assume that this doesn't work because I would imagine that we cannot work with... like, this is too much of a hack, I'd say. So how will we fix it? We will fix it by just mem copy, I'd say. So instead of this, we will use mem copy, mem, oh my god, mem, what? This. So I don't remember the parameter order, so let me Google it. Mem copy parameter order. Mem copy, mem copy. For anyone curious, what do we provide? We provide the target, the source, and the size in bytes. Okay. So the target is this by pointer, so we provide a address. This is target, the source rather. What is first again, source or target? Target is first, so yes, so this is correct then. Then we provide our target, which is our message, was param bytes rather. And then we provide 8. And let's see if, oh my god. Let's see if it will crush us again. Let's restart. And let's run. Missed click. Missed click. Terribly sorry. And let's run it. Let's wait for the motor to calibrate. Let's open our parameters. Nice. And now let's send a value. But let's also remove our breakpoint. Do not stop there. Because I would imagine it just should just work. And it doesn't. Was. Why doesn't it work actually? What the hell? It didn't work with memcopy as well? Oh, maybe it's because maybe I cannot use pointer to 64 on a 32-bit architecture. And if I cannot do this as well. Oh, that's annoying, but sure. Annoying, but sure. Let's try to hack it, actually. Let's try some hacks. So type def union int 64 i64 well, and then let's see int 32 t i32 vals of 2, and this will be e34. Actually, no, let's do it like like this. U int 8t u8 vals, and it will be 8, and this will be u8 to i64 conversion. Let's see if it works. So here, converter, and let's see. Actually, let's move it to our global domain so that we can see it. And where am I? Where am I actually? Hello? Here. This value. Now that we are here, we should be able to use memcopy, right? Just with this. And this is a pointer, so it should just work. So let's try. Let's try. Let's run it. Let's wait for the motor to calibrate. It did it. Let's also put our converter into our. It did. Very nice. Converter through our live expressions. Let's open it up. And let's see. I am sending the request now. It's still broke. Holy cow. Why are you broken, brother? So it still didn't work. Actually, let's remove everything. Like, why is it breaking? Can I do anything with this? Anything at all? Like, what? Run. Unfortunate. So the motor finished calibrating. Let's send the request and oh, hold on a second. So even without me doing anything, we get an infinite loop. What? So even with here, even when we have no code here, we still got an infinite loop when we call this. Why? Why is this happening actually? I think we are out of bounds, so we are reading into the memory we don't have access to. What? Actually, no, I don't remember it for now. Let's see. Okay, so are we doing something terribly wrong here? So what I'm saying is that I'm taking an address of this value, and this is what breaks it, right? Is it? But I can do this. I should be always able to do this. It should not break anything, especially it shouldn't be a type dependent thing. Just for my sanity, let's actually write a float value to make sure that nothing in a different location is broken, that this part works in general. So we are flashed, we are run, and let me remove the U64 value and send instead this value. And let's run it. It was sent and it was received successfully. So that part is working. What kind of garbage do we receive there? Actually, let's keep going. We are, the problem space is very small. I just have no idea what's happening. So our problem space is very limited because these are not the causes of the issue. Let's go to our utils then. Very interesting. Not here. Yeah. We have a breakpoint at this point, and let's me move back my U64 code. Let me send it. We are here. Let me see variables, and let me actually see the last expressions. DMA buff should store buffer should store the whole message, and it stores something. So it stores number format hex. I need to refresh it, sure. Let's go again. We go again. It was so easy until it wasn't. Classic. So easy until it wasn't. So, motor is calibrated. Let's send the value. I'm sending it now, and we are here. We only have 9 values. Why do we only have 9? Even though it was written that we should have 13. What? What? Okay, so let's actually variables. So it says we're supposed to have 13, but we don't. We only have 8, 9. So we don't have 4 bytes. And 4 bytes is just half an int. So maybe there is an error here, actually. So let's see the code. Q and param value. And let's actually print this value. Print message. Save and run here. It will crash, restart. And let's see. Do we have a pack value correctly? So let's send it. The value is okay. Okay, print. Print. Okay. I think this should work. X for X and equals this for X in message. I think this should work. Should it? No, let's actually, I'm not sure this will work. Actually, let's do it for X in message. Print. This will definitely work. This will definitely work. And I'm not sure about this. So let's do it. Should we restart? We should, definitely should. Let's run and let's restart. And let's remove the breakpoint temporarily. Are we calibrated? We are. So let's send it. And this, was sure. We are in infinite loop. So it stores. But maybe this is correct actually. So it's supposed to be 3 zeros in the end. Because we provide 9 billions. And 9 billions are just power of 2 higher than the EU int 32 biggest value. Okay, so zeros there are expected. Let's just, for my sanity, do this. It still should fit nicely. I just want to make sure that we have one more bit of data at least. Let's restart and make sure that our code is in a running state, of course, and it will break again, but let's see what we'll have here. Are we running? We are. Boom. We are in infinite loop. Sure. Yes, we have quite a few values. Okay. And given that we have quite a few values, where is our code? Our life expressions. Yes, we have more. We have more here, but do we have the same? So we have 33 and 35, and it is a correct value. Sure. So this looks correct then. So the data is transferred correctly, which means... Why are you breaking? You don't have a reason to. Like, what's happening? Why are you here? It makes no sense. Wait, but hold on. Hold the heck on. Actually, let's switch to decimal. Let's restart. Because I would like to compare all the numbers. Because it seems to me like some number is missing. Run. DMI buffer. And let's send our value. Okay. So. Here. Was? Oh my god, why is it negative? Ah, sure. Sure. How do I print Python print hex? Why is it so hard? It's just hex. Okay, let's try. Hex of x. How do I synchronize you? How do I synchronize you? And let's change to hex here. And let's restart. Why are we spending so much time here? We are not supposed to. Run. Open. And let's see, let's send. Okay, so AA5570. Should be 70, but it's 2 for whatever reason. 8, 8, correct, 34, correct, EE, 13, 78, TA, 21, 21, 23, 0. So what the hell is happening here? What the hell? What the hell is happening there? Okay. Something is definitely happening. But what? You ask me, I have no idea. So, do we at any point in this function touch? Oh, we do. No, we don't. Do we? Hold on a second. Oh, hold on a second. How many of those we actually touch now? We don't change this at any place deliberately. So we're not hearing anything here. But we are here, so at this point, this should be... What? What? Oh, I know. The 2 is that the protocol is cancelled by the master because... okay, sure, that makes sense. To not see it, let's actually remove this line. And let's do it again. Let's go again. Let's go again. We can do it. Actually, thinking about it now. Hold on. No, let's just test it for now. We are running, we are calibrating, we are looking at the values. We are done calibrating. Let's run it. Now let's see the values, and they are 70. So everything is as we expect. But there is an issue, which I don't understand. What is happening and why? And why? So, what else can we change? What else can we try? At this point, what will happen if we don't call this? Will it also crash? run, and let's send a request. Will it also crash? Am I stupid? No, it didn't crash. Okay. So if we are not calling that, it doesn't crash. Okay. Okay. What? What is that? Am I stupid? Actually, reasons, bits, okay, hard, okay, STM32, hard fault bits. Sorry for the flashbang. I just need to see the register. The fault exception other than hard fault can be enabled by writing system handler control state register. What? To help detect what type of error was encountered in the fault handler, fault status register. Okay. And where are they? Where are they? This table shows types of faults and place function in their own sections. Okay. Faulting and determining the core register. Okay. But I just need to see the register. No. This is too much stuff I don't need actually. There is a simpler solution we used before. Hello? Actually, getting hard fault when assigning this 32-bit value to shown variable. Okay. Unaligned access which causes hard fault. Okay. When you try to access a memory location using the compiler generates 32-bit word access instruction, this word address must be aligned. Oh, what? What? Oh, hold on a second. What? But it should still work then. But we have 3 bytes there. Oh my god. I see the issue, I guess. Do I see the issue? I do see the issue, I think. Oh no. Oh no, I think I know the issue now reading this. Oh no. This is actually such an interesting issue to catch. Oh, okay, let's see. If my solution will now be correct, this is such a nice bug to have, actually, such an interesting one. Okay. I think I know the problem. I think I know the solution. It's just, oh. So, how do we solve this? We solve this by providing a buffer array. So, I think we solve it like this. Let's say static uint 8t aligned value return array of 8. Done. Here we do hold on a second. 3, 4, No, this is correct. We do... Actually, will it work? Not sure, maybe we will have another crash here, but we will be closer to the solution. Mem, copy, UI, target, which is here, and distant source, which is message +5, I guess. Or, like, I like this more, but I think this will crash. I like this more, but I'm pretty much sure it will crash. Here. Let's try it like this. Let's try it. Okay. Oh, let's not. What? And where is it? String H. Sure. Are you happy now? You are. Okay, let's try it. Dun, 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 dun. Let's try and let's see. So we are running. We don't have breakpoints. We do have live expression. And what else do we do? What else do we see? Oh, maybe it will be... maybe memcopy will not work, actually. Oh, this is so annoying, actually. But... let's just try it. Let's just try it. I'm sending the data, and we haven't had a crash. Okay. Do we have the value stored? We do have the value stored. So it worked. Oh my god! What was that? Why? What? It worked. Let's switch to decimal. And let's restart. Let's do it again. If anyone wants an explainer what happened, I can explain what happened to the best of my ability. Okay, so we are collaborating. Let's try it again. I'm sending the value, and now it's sent, it's saved, and it looks correct. Okay. Fuck me. Man. Let's try to break it again, actually. Now that I solved it, I would like to see when it breaks and when it doesn't break. Now that I solved it... I'm stupid. Oh my god, no bloody way. Stop. No. No, no, no. We could have solved it like 30 minutes ago, no? Don't tell me this. That I can put my address of this here. But I don't need... No. Hold on a second. Here. An address. And message. No. Param bytes. Whew, okay. Let's try... Oh, no, 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 no. Let's close this. And let's actually use this. And let's try it again. I will be so pissed if it works. I will be so very much pissed. Run. So let's more calibrate. And let me send the value. Are we done calibrating? We are. It works! Oh, I'm going to cry. Alright, alright. I learned something new, I guess. Sure. And sure. So it works now. And it wasn't working because we were trying to make a U32 pointer to the memory that was not aligned to U32 because our first byte of the value was 6 bytes of the message, so it was not aligned with the start of the 32 byte register, which it was supposed to be aligned with. And given that we tried to get a big address, it just crashed. Okay. We learned something new, and now I am actually surprised that all the other ones are working, because all the other ones are actually supposed to have the same issue. At least this will work just because how the message is structured. This will work always. But this and that should also crash in my opinion, but they don't. And I don't know why. But let me add. This should probably crash. Figure out why it doesn't. Same here. Okay. This is the fix here. This took way more than it's supposed to. way more than it was supposed to. Okay. What else? What else? I'm so annoyed, actually. I'm so annoyed. Let's now flash it. And now let's fix our example that writes everything like this. Let's make sure that it works now properly. And let's make sure it works properly now. Let's run it. Let's wait for the motor to calibrate. It did. Let's remove this and that. And let's run this again. And it seems to work. Let's check the parameters. It worked. So we managed to save everything. So our write command officially works, and it took 1 hour more than it was supposed to. I'm so annoyed by this, but it works. We can put a mark on our to-do list. Okay. Nice. So, now that we are at it, let's do what exactly? Let's change the Python example to be more useful. Which one? Not that one. That one is already useful. but this one. So here we will have to add one more line. Let's actually open it up. And this will be required to true. Test parameter value. The root declarer. And the type will be, oh no, so now it's, oh my god. I cannot do this because I cannot get an arbitrary type from console. Can I? Can I actually, let's see, arg parse arbitrary argument type. Let's see. This kind of hackish way, but it works. Okay. Add argument type int. Add argument foo. Parser unknown parse known args. This is an internal method which returns parsed the same as what parse args would return, an unknown. The remainder of what? Okay, that's annoying actually. Let's not do this. Let's keep this example as fully manual. Fully manual. And if it is manual, we will not have this value, so we will send, let's say, 10 points. Actually, but if we have it as manual, do we even need this? Given that we have another example. Actually. Okay, let's it exist for now. I will think about it later. Now, after struggles and suffering and tears and hitting the table 2 times actually, we can start working on the multi-stream debugging. Now, how do we do this? Let's extend our debug protocol. So let's go to our development mode. And how will we do this? Let's open our protocol.h. So this code is used for write request, and we have codes for streams here. We have to have a similar mechanism with buffers, which we should be able to create a stream and to register a stream. So let's first implement the behavior in the code. And after this, we will change the protocol itself. So let's first make sure it works conceptually. And for this, we need to go and to actually change our utils. So here, currently we have structure for our, where is it? Okay. Oh, for debug buffers. Sure, we should have the same for debug streams. So let's actually just copy it for now. Stores all possible is not correct, all registered buffers. And this will store all registered streams. Okay, so it will be hold on a second. Oh yes, it should be an int, not int, but rather a void pointer. But here we don't need a void pointer because we only have a single structure of stream. So we just have to have an array of streams. So this will be, here we will have, where is our stream description? It should be lower. Oh, it's here, okay. So let's actually move it lower then. Yes, I'm working on it right now. So, debug.com stream. Streams. uh, registered streams, and let's add this as a value. So how many streams would we like to register at most? If this value is 32, let's say we will have one less, not one less, but one power of 2 less, which will be 16. And this is why, because we need to send 2 messages, we need to send a description of each stream and the stream values themselves. So we will have to actually, hold on a second. Okay, let's put it as 16 for now. And it will be named max, debug max, streams count. And if it's not defined, define it, and let's use it. Yeah. Okay. This is not needed here any longer. Okay, but oh no, this will be much harder because we cannot work with streams as we work with buffers, because buffers, we register all of them, and when we would like to change the buffers types we would like to send, we just remove all of them and register new buffers that we would like to send. And for streams, we would more probably like to register or remove them. Do we actually need the remove functionality? Because if streams exist, it's highly unlikely that the stream will be registered locally as a stack variable, because it makes no sense. It says then that because streams is supposed to stream data for like duration of time, maybe infinite duration of time. And if it is a stack variable, the stream will die as soon as we are out of the scope of the function that we are defined the stream in. So it will only make sense to make streams in the main function, so its stack duration is infinite. Otherwise, streams make no sense. So maybe I will not complicate it, and I will just make that streams are either registered or we clean all the streams. So let's actually do it this way. I don't see a reason for me or like a high motivation to implement the ability to remove a particular stream from the registration registry, because okay, it will be just an overcomplication. I don't remember what it does. This one. So actually, so it will be then stream. No, debug streams. Debug streams. I think I need to rename this actually. Do rename to better represent the functionality. Okay. Now, with ability to store multiple streams, we now need the ability to register streams. How will we do this? How do I handle actually debug buffers now? Let me see. Do I register? How do I register them? Let's see. How do I do this now? Register buffer. Protocol buffers. I see. Makes sense. So it will be a per protocol instance, which makes sense. Sure. So per protocol instance makes lots of sense. Let's add it to the protocol then. It's in H. Not this H, but this H. Here. So com stream will be here, but this will be to do remove, and we will keep it here for the backward compatibility for now. But here we will add debug streams. Like this. Does it make sense? It does. Now, as we had with buffers, now we need to have register buffer and unregister all buffers. We need to add similar functions, but for streams. So register stream and unregister all streams. Okay. So the protocol, and this will be debug stream ptr. Do I even need to say that this pointer? Oh, let it be like this, and I think this should be clear enough. This should be clear enough. Let's update it ptr to make variables shorter. Okay, now debug data type, we don't care. We only need a stream, right? We only need a stream. Correct. So let's go and implement them then. They shouldn't be very complicated, so let's just do this. The mechanism will be very similar to buffers for now, but there will be differences later. So this will happen again as well. It will be just streams. And actually, now that I have them together, I would like to go here and then remove this, because it will still be buffers next free index, because buffer index doesn't make sense. So let's rename this. It will break everything. So whatever, let's go and fix it. Let's go and fix it. So it will be breaking here, just this. Oh, it's only in two places actually. Okay. Sure is enough, I guess. Also here. Here, here, and here, and here. And also here and here. Okay. This reads better. Buffers next free index. Sure. Now, we will do the same here. Next free index, and especially makes no sense given that we are working with streams. Registered streams, sure. Let's go back and let's change this. Like that. Nice. And this code will actually be almost identical here. Protocols, streams. Oh my god, 3 amps. Bugs, max, streams count. Okay. And here, too many buffers, too many streams are already registered. And this will be, let's say, 44. Now this will be 46, and this will be 45, 46. And this will be a stream pointer. If it's 0, node pointer, sure. And this is not important because we don't use it here. So protocol streams types we don't have here any longer, because streams contain their own information. Actually, should a buffer contain its own information? Hold on a second. No, it will complicate things a lot, actually. Let's not do this. Ooh. So streams here. Streams and streams there. Next free index, and this will be streams. Streams? What? Registered streams. And this will be of streams, of course. Next to the index, and this will be stream pointer. So this is a stream registration, so we can have multiple of them registered, and we can unregister all of them. Very nice, very easy. Do we need any other functionality here to work with those? Let's think about it. Where the hell am I? I am here. Okay, let's go here. Actually, is it ever used? Debug streams, debug buffers. Where are they? Is it ever used? Not here, but here. Search. I see. So this is just how many times we read the particular buffer. Why do I need this information? Maybe I had a use case in mind, so I will keep it in buffers because it makes sense, but in streams it doesn't make sense. So stores the number of time the master read this buffer. This to do is done. Here, this makes no sense then because we don't care how many times we subscribe to the stream or unsubscribed from it. Okay. Okay, so streams are registered. Let's see our function definitions for buffers. Do we have anything else? Queue message, update message queue. So is this actually it? Oh, is it that simple? Do we... Oh, hold on. Is it that simple? Is this that simple? So shall we make a verification function for streams to be able to verify them on during development? Let's do it. Why not? Let's do this. Let's add a stream verification function that should check that stream is set up properly as a data structure. And then we can actually start implementing the protocol to work with them, to use them. So, right? I think so. We need another function here. Here. So, void not. It will not be void. It should return an error if the stream is set up incorrectly. So it will be pif error. Oh, yes, it should, because we should not register a stream if it's... Oh, actually, let's do the check inside the registration function. Right? Because otherwise stream cannot be used anyways, so who cares? And when we register, we need to make sure that it works correctly. So verify that stream is properly described. Okay, so our stream pointer is active, must be 0 if not equals 0, error, because stream that is not registered must have is active as 0. So log error 9911, I don't know, 891112, whatever. Actually, let's do it like this because we'll have quite a few errors here. So unregistered streams have to... Oh, actually, have to have is okay. Must not be assumed to be active. Unregistered, sure. Now thinking about it, I had a thought, and what was the thought? It was faster than me. I guess I lost it. What was the thought? Oh, the thought was that here I should probably iterate through all the streams and make sure that I just stop them. So actually for uint 32t I equals 0, I less than protocol streams. Oh my god, brother. Hello. What's happening? Sure. Oh my god, e plus equals 1. Protocol. You stop. Streams. Like this. Is it correct? Because this is the next value we will write to. This is the next empty value. So we will go up to this without using this value, right? Correct. And here we just force our stream to be inactive. Right. Oh, we will have to actually use arrays quite a few times for streams, but this is fine. So let's just make sure that our protocol dot streams registered streams at I dot is active equals no. So we are force all streams to be inactive before clearing the registry. Okay. So now this looks correct. Now let's keep our error checking, and for this we'll need to see our streams, of course. So let me open this to the side. Where the hell am I? Oh, here. Sure. So the timeout, we don't care. Whatever the value is, we don't need to check it. Message. So message must not be 0. So stream pointer dot message must not be null. Null is not defined here, so it might not be pointer to 0. Okay. And the error will say that the stream must have a defined data carrier. Okay, next. What is next? If what? What else do we have? Message byte size, number of bytes per single stream message. Okay. Can we verify this? We can. It's just a bit of work, but I'm getting tired. We'll finish this up and finish for today. And given how often I catch some weird bugs, we might as well sit here for like 3 hours. Okay. So, entries per message. Okay, let's see. Number of entries that are contained in a single message. Sure. Let me think for a while. For a bit. ID must not be 0, so let's see. Let's first check the easy ones, and then we will check the complicated ones. So stream pointer this will be ID equals to 0. Another error, another easy one. Stream ID must not be 0. Very easy. What else? Entry fields is active, entry fields timeout. So, okay. Now, to check if we are correctly set, we have no idea, like we cannot change the size of this because this is a void pointer. We just have to assume, have to trust, have to believe that the user pointed a correct structure or correct array to this pointer. We cannot check anything about it. We only can check that it exists, that it is not null. We would want to maybe check if it works, but we cannot. We effectively cannot, which is fine. What we can check is that our field types and our byte size are correct, if they make sense. So, how do we do this? Do I have an array that gives me sizes of these things? I don't think I have anywhere, right? How do I actually check it in the protocol? So let's open the protocol actually, and let's see if I have it here at any point. If I have an array with sizes, and this is not needed anymore, given that we found the error. So no, and how do I do? Oh, I see. So this is how I do it. This is not a nice way to do it. So how we will do it actually is, let me cook. It will be static int32 debug data type size, and this will be 0, 4, 4, 4, and I think I will make it like this. To explain it properly, it will be 4 bytes. Actually, this should be an array. And I don't need to put a length here. Like, if anyone is watching me from the very beginning, we are using quite a few advanced features from C here today. If anyone is struggling to follow, ask questions. I am happy to answer. So, let's continue. This is a 4 bytes. This is a 4 bytes. After that, we have 2, 2, 1, 8, 8. Oops. Like this. Okay. And put it here. It will be 2 bytes. And put this here. It will be also 2 bytes. And why do we do this? Because, like, this code will be simplified, and if I will ever change definitions of those, this code will be like still functional, given that those are connected and related, and we will change all of this with a single line. With a single line, which actually will look like this. Data size multiplied equals debug data type size of buffer type. So we will exchange all these lines with this line with a single one. So let's keep going. Boots. Sure, bytes here and here. Oh my god, my brain is melting today. And here, bytes. Very nice. So now this should work. And what function is this? Is read buffer properties. Actually, do I at any point in here call this? I don't. Okay, this is fine. This is absolutely fine. So this should work. Let's test it. Let's test it and let's flash it. We have an error, and the error is what? Oh my god, what is what? Hold on a second. What? Maybe I cannot do this. Can I do this? Okay, what is the problem actually? Oh, I see. Do we have other problems? Incompatible times when assigning the debug stream from the debug stream pointer. Debug stream pointer. Sure, that makes sense, kinda. Let's see. Buffers, and these are. Oh, this is array of pointers. Oh, hold on a second. So I need to provide a pointer there. Sure. Wait a second, but I do provide the pointer, right? But I need to store pointers to. Yes, I don't. Okay, I need to store pointers to the streams, not the stream copies. This makes sense. So it will be an streams rather. It will be not an array of streams, it will be an array of pointers to streams. This will make sense. This will make so much more sense, actually. But this will also break, but this will fix it. I think. What? This. Okay. Now let's flash it and let's see if it works. One moment. Uno momento. One moment. Okay, I'm back. I'm back. And now let's test if it works. We are not testing this functionality yet. We are just testing this functionality. And I think I need to add a flag that is okay to be not used, because this will be included in quite a few places as a copy. Right? Yes. It will be copied in every translation unit that uses debug utils, which actually is kind of annoying. Is it? Can I do it better? I can do it as an extern, but extern is quite a breakable thing. I don't like using extern. But I also don't like my flash to be like huge. On the other hand, I can just use int h here and it will force us to use direct data conversion quite a few times, but it should be all right. It should be all right. I think so. Okay. So let's use it like this, and let's also add a flag that it is not used and that we are fine with this. Shall we? Shall. So where can I see the flag? I can see it in my clocking examples, actually. And where are my clocking examples? They are in SDK, and our SDK is here. So attribute unused. Let's copy this one here, and this should be absolutely all right with no warnings. Now, we should flash it. And we should test it. We should test if buffer reading still works. Because if it doesn't, I broke it. But it's easy to fix. Should be very easy to fix. And run. And now let's wait for motor to calibrate itself. And let's see. So move back, please, Mr. Motor. Nice. And now let's read our. Let's test right works. So Python. Oh, actually, I think I need to remove this. This was a debug line, of course. This one. Not needed any longer. Do I have anything else? Do I have anything else? I don't think so. So let's Python com save debug buffers. It works, it still works. So I haven't broken anything, which means that this can be a two-liner. Which means I can remove this. See, so it works. It works very nicely. Remove this, go here. This is very useful, very useful to make the code looks nicer. And now to be able to count the data size, which is also very nice. So, how do we do this? How do we implement that? Should be easy enough, I hope. Okay. So, should be easy enough. Actually, let's go first and remove the comments from here. They are not needed any longer because this implements the functionality we would like to have and makes the code shorter. What the fuck is this? Okay, this is annoying. Why the hell? I never used it. Okay. And let's go to our check function. Let's go to our check function. And let's see it. And let's see it. Okay, I think my brain is melting completely today. It's quite late. But we will finish this task today. No questions asked. And they should be here. So very nice. we have our way to get values. So uint32 t index equals 0, while, okay, let's see, int32 stream byte size, stream size, okay, stream entry size bytes equals to 0, and while for stream oh my god, pointer stream pointer entry field types of our index not equals to no type, we stream entry size plus equals to this thing of this actually. Okay, very nice. What is wrong here? Missing where? I don't think I miss anything actually. What are you saying? And index plus equals 1. What? Oh, I see. While. Happens to the best of us, I guess. Sure. So this will allow us to calculate the size of the single entry. And now what we have to do is make sure. Oh, this is so easy actually. Now that we implemented this array, this is so easy. If our stream pointer dot message byte size not equals to this multiplied by stream pointer that entries per message count. So if they are not equal, we log another error. This, and this says that message byte streams message byte size is specified incorrectly. Okay, so now we can test it. We can test it quite easily actually. So let's do it. Let's do it. It should be incredibly easy actually, and we can test all of them. Right. And also, I think that after any error, we have to return, because it doesn't make sense to use. Actually, at this point, we can fix it. So this is fixable by this. This is not fixable. We need to return. Return. This is not fixable because we have no idea. Because 0, like we cannot fix it because we have a pool of 254 available IDs and we have no idea on how to. Oh, actually, I need to do another verification here. Oh, man. Streams will be a pain in the ass. Having a lot of them will be a pain in the ass. But. No, this is actually fairly easy. This will just require quite a few loops. So here we'll also have to, okay, let's finish here first. So we cannot fix this. So this is fixable. So we keep going. Is fixable a word in English? Let me see. It is. Okay. It is a word then. So this is kind of fixable. So we can fix this by specifying the correct byte size, but we don't know where user made a mistake. We don't know if user specified size incorrectly, or if user specified the stream entry count incorrectly, or if user specified stream types incorrectly. So we cannot help it. Like if we knew exactly where the message is, we could have probably helped with some of the issues, or some of the cases, but we cannot unless we know where the issue is, and we don't. So here, what do we have here? Here we need to check that our ID is unique, because if our ID is not unique, we are registering streams. Oh, actually, now that I'm thinking about it, why would I specify the stream ID manually? Right? So I can make a design decision that stream ID is actually not the ID you specify as a number, but rather its registering order. And this will make so much sense, because then we can just use ID to also use it at index in the array. To use the stream ID as an index to the array. Right? I think so, but this also raises a question if we even need to store the index, the ID rather. Like, do we even need to store this? Because at this point, it makes no sense to store it. So maybe actually the ID concept for streams is redundant, given that we have now no IDs just by the locations in the array of streams we register. So actually, let me, rather than doing this, let me add, let me explain what I just explained as a to-do for myself. Remove stream ID. Now that we can have multiple streams and the ability to switch between them, we don't need ID any longer. ID will be their index in the registered array, and that can be used both by both master and slave devices, like that. So now with this, we are finally implemented what we wanted to implement, and I think this code should stay here. We don't need to separate into another function, because we would like this code to return this function. And if we put it to another function, we will have to do a wrapper that will check if the error code is returned, and then return again. So it will be annoying. Return chain, and we don't need a return chain, so we'll keep it here because we only call it once anyways. Now, unless we of course want to use it for checking, but why would we use it for checking if this function is using for checking? Because we cannot do anything with streams without registering them. Which makes a lot of sense, actually. This is a very nice design, I would say. So now we should test it. So let's test it and finish for today after we tested this. And how will we test it? We don't even need to update anything in Python yet. What we need to do though is just calls functionality. So here, let's add it here. And let's add deliberately broken stream. So let's say broken stream. And it will be broken in all the ways we check, so that we can check the behavior of the error checks. Oh, okay. So let's move it here so that we can see what we need to change. And now we will use this value here, but we will remove it for now so that we get an error. IDs are not important. We put 1 here. Let's say we put this here to mess up everything. And let's see, I think this is enough. This is a broken stream, and now we need to call on our debug register. What the hell do I, what the hell is going on actually? Debug ITF register stream, and it says that I also have a debug register stream, stream. And what does this function do? Oh, hold on a second. What does this do? Or is it an artifact of us not removing this yesterday? Oh, it is. Okay, so this can go then. And this can go then. Okay, sure. Makes sense. Then this will go here. And this should also have a separator of sorts. To do at a proper separator. And now let's test this finally. So this function doesn't exist any longer. This function does though. So let's register our stream, which should break all of us in every imaginable way. So a broken stream. And we should see a few errors. And we will fix them one by one and see other errors we are getting. So let's do it. We are flashing. We are flashing. So let's see. Now we are here. Let's make sure that our protocol is here. Let's see our streams. We have now registered. These are pointers, of course, to our streams. And let's run it and let's open our error log. And we should see some errors. So we have 8910 and 8913. So let's go to our implementation and see what those mean. What have we caught here? So we caught that is active is 1, which is correct. So let's fix it. For example, we are in a development environment. We saw this error. We think, okay, I'm a dumbass. I need to put it to 0. Sure. We go to, oh, it should be like this actually. Oh, and this we will actually remove. To do remove, given that IDs are not longer necessary. I'm not sure this word necessary used. It will be a better word. I know the spelling of. So we caught this error though, which is fine. So we will fix this error by removing the unnecessary bit explanation, and let's flash it again. And we should caught this error, but none of those two. So let's do it again to make sure that our broken stream is fixing itself. Or rather, we are fixing our broken stream. So run, check the error log. We see that our error is 8911. And 8911 says to us that we don't have a carrier for our data. So let's add a carrier for our data, for example, like this. And let's refresh it again and see if everything will be fixed. And run it, and let's see error logs. So we have no more errors, which means we solved everything, and this broken stream can now be called fixed stream. Okay, but we don't need it any longer because we know that error checks are working correctly. So we will be notified by our system if we are using incorrect specification for the stream. Very, very nice. So here, let's add our test stream because the approach to the registration has changed. Now, given that we've done this, now we have to go and implement the protocol part. And the protocol part will be like what? So our master will have to make a request which will say how many streams do you have registered. And the slave will respond, for example, 3 streams. And can the slave send stream descriptions with this message? Like, will it make sense? Because if it can, like, stream descriptions are quite long. They are 13 bytes. So if we, for example, have 16 streams registered, it will be like 16 multiplied by 13 plus like 5 of bytes rather of header, which is quite a lot of information, but also not that much. So we might as well just give the master all the descriptions, and then the master can select a stream that it would like to subscribe to, right? And also we need an ability to unsubscribe from all streams, and the resubscription to another stream will be done how exactly? I think it will be handled by a slave. When we just get a new subscribe event, we unsubscribe the last subscribed stream and we subscribe to the next stream. And this means that we need to know the index of the stream that is active. So let's actually add it to the structure then. In this architecture, we have to know the index that is currently active. And if this is the case, we can also simplify another place. Okay, this simplifies the code so much, actually. This is such a nice idea on how to handle it. Let me implement this. So where should it be located? I think here. So debug streams will hold and uint 8. Currently active stream. No. Yes. Active stream IDX. So this will be an index of the currently active stream. That's a stream that is currently subscribed to, and we can only be subscribed to one stream at a time, which is a limitation or rather a rule, because I will find it very hard to believe that it is easy to implement subscription to multiple streams through the single medium. It just sounds like a lot of work. Actually, it's kind of possible, but kind of pointless. Or is it pointless? Because if you need to subscribe to multiple streams, just create a single stream that has values from all the streams. Like, why not? On one hand. On the other hand, actually, like, a big decision should be made here now. Do we allow a user to subscribe to multiple data streams or not? Because what it will mean is that we will schedule multiple streams at the same time, and they will send the data. But what the point of this can be is that one stream can be very slow. It can be like 1 time per second, and another stream can be like 5,000 times per second. 1,000 times per second. So from this point of view, I actually believe that I should be able to register multiple streams and to have multiple streams active. So actually, I will make a design decision that we will have multiple streams active at the same time, which means that our unsubscribe will work as it works right now, which also means that it will be a problem on the master side, but not on the device side. Device side actually, oh no, hold on a second. No, yes, it will work. It will work nicely. It will work nicely. So we just need to know what exactly. No, but this means that we need to store the ID. Oh my god, this architecture is so complicated. Holy cow. Okay, so then we need to store the ID because we need to update multiple streams at the same time. We need to know what stream to update, so we need to add this to the update function. So where is our update function? Oh my god. Oh my god. Okay, where is it? Where is it? Where is it? It should be in the protocol. No, it should be here. Of course. Yes. But it should also be here. And this function has to tell us what? Oh no, but that means that we will have to have many of these functions, right? Wait a second, let me think about the architecture better. We can do what? What changes can we make? Because this is annoying. It is annoying because this function should be implemented in the user code. And if we would like to allow the user to stream data from multiple points, from multiple streams, then this function should be called multiple times at places that are reasonable for the stream, for each particular stream, for each specific stream. Which means that if we have only a single function, this function will have to be complicated with if-else to check what exact ID of the stream we would like to work with. Is it a problem? Yes, it is a problem because we don't know the registration order. No, we do know the registration order. Actually, yes, I decided again. So ID will stay, but ID will be set here, whatever this is. Remove this. This is not needed any longer because this is implemented and works correctly. This works as well. We've tested this. So at point where we check the stream registration here, ID will not be needed here because we will actually, okay, if all the checks are passed, this means the stream can be registered and the stream will have stream pointer.id equals to, IDs will start from 1 then. It will be equals to this value plus 1. So we provide the ID for the stream during the registration. And this ID can be then used for the stream to be called upon. And this is very nice. So the stream, we can call the specific function for the stream based on this ID without knowing what ID exactly is, like without caring about the registration order, which is nice. Now, oh my god, it's so complicated. Now, what now? And now we need to think about and decide what we do about this function. So this function, like we have multiple ways to do it. We can either provide callbacks based on the ID, but this is terrible. Oh, hold on a second, actually. But if we will know this... okay, so I decided as well. I see a nice solution here. So it will be just uint8 t ID to update. So we will change the protocol to this, and this will be implemented in such a nice way, actually. Oh, I will show it now. Oh my god, it will be very nice, actually very nice. Okay. So first of all, we need to change 3 places where this function is called. So let's find them first. Search, and this is a place, because this place will actually, how it will be called now, given that we updated the way to use it, it will be called like UART protocol. Oh, hold on a second. The protocol holds ID itself, right? Yes, it does. So we don't even need to provide it because it's already provided inside the protocol then. Oh my god. So we don't need to change it. We just need to change the function itself. And the function itself that is implemented in the... where exactly? Okay. So here is an important part. Oh, but we don't need to change anything at all, actually. Holy cow, it just works. It just works. Because we call this update function per instance, per protocol. No, we call it per... no, we call it per protocol, but we need to call it per protocol and for the stream ID. Oh my god. Protocol. And we do need to specify ID then, right? Because this one relies on the com stream to be active, and it's also... yes, we need to change it. Oh my god. But the change shouldn't be complicated, right? We just provide an ID. Yes, let's provide an ID actually. uint8t target ID. And let's provide it here. Because this is the same structure, not structure, but function. And let's also change it here. And here we will... so this check is absolute now, because to do remove after I remove com stream. Holy cow. And instead of this check, we will do a protocol protocol dot streams dot next register streams must be bigger than target ID. Otherwise, the stream ID we try to update is not registered, which is an error. So log error something. I got specified ID is not registered. Oh my god. Okay. Registered. I think I spelled it correctly. Oh no. Whatever. So, is it correct? It is. And if provided ID is registered, then what we do here, we remove this. We also check then. Now we know that we can do a check into the array and we will not be out of bounds. And then we do protocol. So this both will need to go. Both of them will need to go. And this will be protocol dot streams dot no. Yes. Registered streams of target ID. Of target ID dot is active. If this is not active, then we have no, we don't have an error, we just have an return. So master haven't subscribed to this specific stream, so just abandon the data sending. Data sending. Abandon. Like this. And here, this will also change. So all of the code below will have to go. So message stream start will also have to change. It will require one more field, which will be message ID. It will be U8 stream ID. Oh my god, it's happening. We are making it work. We are doing this. Okay. And now we need to put our ID that we checked is active to the third position here. We do it like this will also have a oh no, this will actually have a mutation problem here. Oh, and the mutation problem will happen when we have, for example, subscribed to 2 streams or 3 streams and all the streams are synchronized at some point and they all would like to send data. So we need to store a copy of this. Can we store a copy of this? Can we make it somehow smart? Because we cannot allow ourselves to do like this. Because otherwise, if there are 2 messages scheduled, they will break each other. Okay. So how do we solve it? We can just create many copies. But that will take our flash space. But it's not that much. It's like 32 bytes, like it's 32 bits, 4 bytes per message. It's actually nothing. Let's actually do it. It's nothing. Or how will we do it? We will do it as we will do it as a 2-dimensional array, which with first dimension being our debug streams max stream count. And this should be like that. Oof, this will take a while. Oof. And this has to be done, like it has to be done, like it has to be done to prevent streams from corrupting start message of each other. Streams. Okay. So let's see. This should work. This is 16, sure. So it will be 2, 3, 4, 5, 6, 7, 8. And nope. Like that. 9, 10, 11, 12, 13, 14, 15, 16. Is it 16? 1, 2, 3, 4, 5, 6, 7, 8. It's 16. Okay. It is not beautiful, but it's functional, and it's very functional. It's actually not that much space. It's only like 16 bytes. Not 16 bytes, but 16 words, which is like 64 bytes. 64 bytes is nothing on modern microcontrollers. So it looks scary, but it's actually not. So, and it helps us to prevent a corruption issue. Right? Right. It's very nice to do. And also, now thinking about it, I think I can do the same thing, and I probably should do the same thing for buffers, because it will prevent a corruption issue for buffers, which is possible. Right? No, I don't think so. I will add a to-do for later. To-do, think if this approach will be useful for debug buffers as well. Okay. Now, let's finish implementing it. And how do we implement it? Instead of sending the predefined message, we will send a predefined message from an index. Which is fine, So let's do it. Let's just do it. Where was our code that we had to change? Was it here? No, I think it was, oh my God, I don't remember now. No, it was an update, so it was in the implementation, so it was in the UR debug protocol, so it has to be here. Just lower, here, perfect. So we cannot do this, but instead, we can do this is now an array of arrays, of course. And we are, for readability sake, let's say uint8 pointer to message start. And this will be, I need to rename the variables later. To do rename variables. And this will be indexed at protocol. No, I don't need the protocol. It should be just of target ID, because we've verified the target ID is registered and we can use it. So target ID, like this. And we can use this and that. And I hope, but this will give me a size of the pointer, right? And I don't need the size of a pointer. I need the size of array. So it will give me, let's just use a hard-coded value of 4. It will work. It just will be annoying to update when, in case we change the message start way, it works. But it works fine. So now, actually, the size of pointer would have worked, given that the pointer on STM32 would have returned 4, but it would have worked by accident. So now, here we need to do a protocol streams, register streams of target ID dot message. We send the message of the stream.
Marriage is now following.
Thank you so much, SH Marriage, for following. I appreciate it a lot. So, and here we also need to provide the size of it, and the byte size is stored, so we just need to change it to this. Correct? Right. Very nice. And let's then move it to 4 lines, but rather 3 lines, like this. And this is relatively readable. So we send message of message size, and we know that message size is correct, given that we specified it at startup, and actually we should make it a constant. So let's make sure that, let's also define a rule that we cannot change stream after startup. So it has to be defined at startup. So, which means that this has to be const. Like, will I regret this decision actually? Will I? Will I at any point regret a decision that I cannot make a stream dynamically? Let's think. Other use cases in which I would love to make a stream dynamically. Because I can technically do this and my master will actually save the data correctly. It will just have no idea what the data is. And if it has no idea what the data is, like, what is the point then? Right? Is it correct thinking? Let me think 1 moment. Does it make sense? I do believe that it does, actually. Like, other use cases in which I need to make streams dynamically. For example, if we say we have variable number of channels on a device and we would like to send data. Yes, actually, I do see the way that I need them. For example, if we make a device like a logic analyzer and we can stream data from 1 to 16 channels, if I make a const here, I will have to do what? I will have to make a new stream for every configuration, for 1 channel, 2 channel, 3 channels. And given that we can just simply select not 1 to 3, but 1, 3, 8, this will actually break everything. Like, my debug protocol will not be functioning in this environment. So from this standpoint, I actually have to be able to change streams dynamically. So no const here. And why did I want to make const here? So that I can ensure that streams don't break in the middle. But how we will ensure that they are not breaking in the middle? I guess by debugging it. Do we need to then make a function to be able to check the stream, for example, after we update them? Yes, let's do such function. It will be useful. Like, this will stay. This will go. I can actually remove it already. Like, whatever. Like this. And now, brain, please function. And now. Oh my god, I can't think anymore. What was I even talking about? I was talking about making things const or not, and which decision I made that I will not make because I would like to make a dynamically allocated. Oh, I remember now. I need to go here and remove this. Okay, but this will break a lot of things, but that's no matter because I will temporarily remove ability to. Let's actually see what's broken. Let's see what's broken. Oof. Let's comment out all of it. Because all of it has to be redesigned. It has to be. And is anything else broken? Yes. Of course, this can go. Sure, this is not a big deal. Anything else? Too few arguments, of course. And here we would need to use our UART protocol, but it will be test stream.id. So this is how it will be used. And No, it's ID. And this is very beautiful. This is a beautiful solution in my idea because it reads nice. We know that we are updating this stream on this ID, which supports both multi-protocol implementation and multi-stream implementation. And the same streams can actually be streamed over multiple protocols, which is kind of nice actually as well. Which is kind of nice. I don't have use cases for it yet, but if we will support, for example, this protocol on CAN bus, USB, and UART, and we can stream to all the targets at the same time. Same values as well. Values are not corrupted by streaming them. Okay, this is actually very beautiful. I like it a lot. Now comes not hard, but rather a time-consuming part, which is implementing the protocol itself. Re-implementing rather, because we had protocol, but it is not usable anymore, given that we have now a multi-stream support. But my brain is fired. It's already too late for me. And I will finish for today. It was very productive, actually, if we not consider the error we were fighting with for an hour. Otherwise, it was a very productive stream. Thank you everyone for watching. If anyone is not following, please follow. I would appreciate it a lot if you want to see more. And I see you tomorrow, I hope. Thank you for watching and bye-bye.